Now we go with a more complicated one in the topic. Okay, so we have what we call exposure field recognition. The computer uses an exposure field recognition program to distinguish the edges of the anatomical part against the background from the edges of the collimated field. The inclusion of data from outside the collimated areas will cause a miscalibration of the histogram and exposure field recognition errors. So ganito siya. Okay, for example, this is your collimated area. Ayan siya. With this black thin line here. So this is your image receptor plate. And this is the collimated area for this anatomy of interest, which is your skull. Okay, so according to the exposure field recognition, it must recognize the edges of the anatomical part itself and also the edges of the collimated field, which is this one. Okay, so kung hindi nyo yan ma-recognize, so the image will be distorted, not distorted, but the contrast and brightness will not be of optimal quality. Okay, so if ever di niya ma-recognize yung edges of the anatomy and the collimated area, this will cause the miscalibration of the histogram and exposure field recognition errors. So later on, we will discuss what a histogram is. Ayan na siya, histogram. The histogram representing an image is constructed by simply counting the number of pixels within the image at each density or brightness level as the computer scans across the entire image. A histogram showing the actual data bars is shown below. Okay, so ayan po siya. This is an example of histogram. So it depends also on the number of pixels on the bottom area and their density or brightness level on the top area. Okay, so for this number of pixels, ganito ang kanyang brightness. For these number of pixels, ganito ang kanyang brightness. For these number of pixels, ganito ang kanyang brightness. Okay, each vertical bar indicates the number of pixels which hold the gray level indicated along the bottom axis of the graph. The peaks and valleys. Okay, when we say peaks, ayan, pinakataas, and then the valleys are the lower ones. Okay, of the graph represent variations in the anatomical structures in the image. These are presented on a simple scale of brightness from white to black, as read from left to right. So that means white ang color ng mga pixels here, or the density of the pixels are lower in this area compared to this area here. Okay, from white to black yan siya. Okay, so that means the anatomical areas here are colored black, no more black, and then this area here is white, and then mag-transition na yan siya towards black. Okay, thus metallic objects or contrast agents would be represented on the far left of the graph. Nasa far left siya because your contrast agents and metallic objects appear white on the radiograph, followed by the bone, then soft tissues, near the center, fat, and finally gaseous or air densities to the far right. Okay, so this area here, ang anatomy na makita dito is those that contain air, such as the lungs. Okay, so black ang color ng air in the radiograph. Okay, so to simplify this histogram, ito po. Okay, so we have first the S1, which is this area here on the first part, and the S2, which is the valley here. Okay, so diba, as I have said a while ago, the histogram is red from left to right. Okay, that means this area here is white, then this one is the area here is black. Okay, so this area of the histogram is the bone, which is indicated by the vertebra. And then this area here is the soft tissue of your heart. Okay, and this area here of your histogram is the air-filled lungs. And then this area of the histogram here is the dark or the black areas or the high density areas of the collimated field. Okay. Histogram of a chest image. Yan siya. Okay, so this is a normal histogram of the chest. The leftmost portion of the bell curve represents the bone densities. The mid portion represents the soft tissue, and the right portion is the aerated lung or with the air. And the spiked tail represents the pitch black. So this area here, ayan siya, is the pitch black background densities. So ito na mga area. For most applications, the computer must recognize the area from S1 to S2 and analyze only this information in processing the image. So dapat ang i-process lang ni computer is from S1 to S2. because this area here is of no significant information man siya. Okay? Because of course, black densities lang na siya, wala namang anatomy. Okay? For most applications, the computer must identify this tail portion, this area here, and eliminate it from the histogram analysis performed. Okay? If these pitch black background densities are included in the computer's calculations, the final image produced will be skewed away from the desired brightness and contrast level. Okay? So if ma-analyze to siya ng computer kasali itong tail, no, the brightness and contrast of the image will decrease because di dapat siya kasali. Okay, ang kasali lang dapat is this one and this one because this area here, this area here is of information, of yung mga important information lang. Okay? Only data from within the anatomy must be included during the processing, which is from S1 to S2. Other variables which can throw off the histogram analysis include positioning and collimation errors, unusual pathological conditions, removed or added anatomy, and artifacts such as prostheses and that are present during the initial exposure. So, hindi lang itong tail na ito, which represents the pitch black background densities, ang maka-affect sa histogram and the final image itself. Okay, there are also other factors such as yung mga unusual pathological conditions of the chest, that will decrease the brightness and contrast of the image. Also, contrast media, which will spike this area here. Okay, and also other factors. Okay, and then here is the okay, so now we go with the initial image processing. So from the technicalities within how the X-ray is converted into an electrical signal, now we go on how to, what do you call this, increase or decrease the brightness of the image, of the final image. Okay, and then now we have this lookup table. Okay, this lookup table or LUT lists the parameters that produce this particular shape of the ideal histogram. In order to rescale the image, the different types of lookup tables are developed which treat the data differently in order to get the very best results in image quality for the particular body part being radiographed. So there are different types of lookup tables na installed in the computer. So there are lookup tables that increase or accentuate. When you see accentuate, it prioritizes the image of the bone. This lookup table will prioritize the image of soft tissues. This one will image the air-filled lungs. Okay, there are a lot of lookup tables. So here is an example of a lookup table. Okay, ayan siya. This is the lookup table for a medium contrast, no? And this is a lookup table for high contrast. Okay, so if you're going to change the contrast from medium to high contrast, ganito ang kanyang mga output na mga numbers. Okay, so of course, as you can see, with medium contrast, the values are lower, compared to the high contrast na mga output sa lookup table. Okay, so as you can see here, this is the role of the lookup table. So from low contrast, then after that processing through the use of lookup tables, if you want to create a high contrast image, ganito na ang kanyang pixel values. Okay, so from 40, which is a shade of gray na lower than 90, and then si 30 naging 10, which will produce a high contrast image na siya because the contrast is now high. So there, it is more on the black and white na picture cases it's a low contrast within the which has gray, which is a gray color. Okay, so contrast is changed by changing the pixel values through the use of lookup tables. From 40 naging 90 siya, 30 naging 10. So from low contrast it becomes a high contrast image. For example, the figure below illustrates how bony anatomy or soft tissue might be accentuated in the final image. In histogram, an LUT was selected to accentuate bony anatomy. Under this algorithm, the computer focuses only closely aligning the left portion of the actual histogram and reference histogram curves. These bone densities are defined as the volume of interest or region of interest and are processed somewhat at the expense of soft tissue densities to the right. Okay. So for example, this one. So we have a lookup table here in a graphical form. Okay? So since dili man nato kayo ma-process, no, ang lookup table in this form, which is used by your computer, we will transform this table into a graph like this one. Okay? So if your volume of interest for this lookup table is in this area, which means your your image will produce or accentuate, no, um, bony na mga anatomy, because again, dito man siya na area. So and in this area, mga bones man ang primarily in this area. Okay, so your image will result like this one on this area here. So as you can see, the bony anatomy is accentuated. Okay, it's parang, what's that word? Focused. Okay, mas focused ang bony anatomy here. Although there is loss of spatial resolution because i-zooman ako na siya ng image. Okay, so never mind the spatial resolution, i-focus lang nato siya sa bony na mga structures. Okay, so as you can see here, it's klaro gid ang bones. If your histogram is like this. Okay, but if your histogram focuses, the LUT of your histogram focuses on this area, which is more on the soft tissue, ganito ang kanyang image. Okay? So as you can see, compared in this one, mas accentuated ang soft tissue areas. No? As you can see here, the soft tissue is mas klaro, no, at the expense of na-sacrifice ang bony detail ninyo. So dapat, isa lang yun ang what do you call this, prioritize. So if you're going to soft tissue, your bony detail will then be sacrificed. If you're going for the bony structures, your soft tissues will be sacrificed. Okay? So if the same radiograph is processed using a soft tissue algorithm, the region of interest will be the right region of the bell curve, representing tissues from dense organs to skin. Okay, so if same gihapon ang processing but more on focus on soft tissues, again, ganito po ang kanyang labas. Okay? So we have three types of LUTs. Again, we are not going to use the table format anymore. We are going to use the graph. So that mas dali siya sabtan. Okay? There are actually three general types of LUTs that are each based upon certain assumptions about histogram that will be available for data input. In a sense, each type of LUT expects a particular shape of histogram and performs its calculation based on this. The important point here is that these three types of LUTs must be properly matched with the actual types of histograms acquired in order to avoid processing errors. It is essential that only that portion of the histogram be analyzed which is pertinent to the type of LUT that will be applied. Okay? So during image processing, we have two LUTs or lookup tables. The first LUT is the one na nakuha nato or na-process nato, and the one that is preset, okay, or pre-made or installed by your manufacturer. Okay? So dapat katong first na LUT na ato ang na-acquire is the same as the LUT that is preset by your manufacturer, so that processing errors will not occur and then the images are of great quality. Okay, again, we have two types of LUTs, or two LUTs acquired. Sorry, you have two LUTs during image processing. Ganun na lang. Okay, the first LUT or the lookup table is the one that we have acquired. Okay, that we have acquired after na x-ray ang pasyente. Okay? And the next LUT is the preset na, okay? Installed na siya daan sa LUT of which na kailangan i-follow sa computer. Okay? So, yun. So dapat, again, i-follow ni first LUT, ang second LUT, which is the preset, so that processing errors will not occur, and then the quality of the image is nice or great or better. Okay? So these are the first type. This is the first type of the LUT. So type 1 histogram analysis is designed with the expectation in the direct exposure area, the spike at the right or tail in the graph will be present. So for example, ito siya. Data from this extraneous area must not be fed into the LUT, so that computer must recognize the location of the S2. So again, S1, this area here, and then S2 kami siya. Okay? So in this type of LUT, your second LUT, which is the present, or preset, I mean, the second LUT, which is your preset, will expect, no? Yes, sir. Mm. Okay, so again, the first type of histogram analysis or first type of LUT is the one that expects no, that there is a spike. Okay, this one may spike siya on the histogram. Okay, so dapat the data from this extraneous area, kanina area here, must not be fed into the LUT so that the computer must recognize the location of S2. Okay, so dapat, again, di ba, as I've told you kanina, dapat remove din siya na area. But your first type of LUT expects this one. Okay, pag processing lang, dapat mawala ni siya so that image ninyo is gapukuha. Okay, so dapat kanina lang yun na area ang ma-process. Okay. For the second type of LU2, type 2 analysis operates on the assumption that there will be no tail in the histogram or background density spike. In preparation for applying an LUT, the histogram analysis must attempt to localize S2 without expecting any direct exposure area to be included in the curve. So this is an example of a histogram of the abdominal. This is an example of abdominal histogram. Okay? So we all know sa abdomen, ang laman lang po ng abdomen ninyo when imaged is bone and soft tissue. Okay? So in this type of LUT, no? So in this type of LUT, wala na yung tail. Nag-expect siya na walang tail, which is your background density. Okay? So for this type of histogram analysis happens manggod when you compare or when you try to align your first LUT to the second LUT. Okay? So that is how your histogram analysis occurs. So in this type of LUT, dapat wala siya tail. Okay? Tail for background density. Now, the type 3 histogram analysis allows for large boluses of positive contrast agents to be included in the projection. It also allows for lead shielding to be used. Okay, for the third type of LUT, during this histogram analysis, it will expect a spike in this area here because this area here is for your shielding, for contrast media, in preparation for a type 3 LUT to be applied, S1 must be identified as the point between the metal densities and the normal tissue curve. So dapat si S1 may valley dito so that it can be recognized as this area here is increased in contrast to siya compared in this area here. Okay? S2 must also be identified during histogram analysis. So hindi lang si S1, dapat si S2 ma-identify din siya. And then all data outside these 2 points must be eliminated from the calculations used to produce the final image. So dapat this area here and this area here must be removed during image processing, okay, after ng histogram analysis, so that the image will only contain this area here, which is the bone and soft tissue for the abdomen. Okay. Now we go with image enhancement processing. So we're almost done. Last part na dito siya. So we have what we call gradient processing. Okay. Gradation processing or gradient processing refers to what most radiographers will recognize as simply adjusting the brightness and the contrast of the image. Okay, so when a gradient curve is plotted on a graph showing the various densities in an image, we can think of the average brightness of the image in terms of where this curve is centered, and the contrast as how steep the slope of this curve is. Gradient processing is all about adjusting brightness and contrast, period. Okay. Older technologies will recognize this concept as the HND curve. So gradient processing is a good term to describe the manipulation of both the centering and the steepness of the gradient curve. So when we talk about centering in the gradient curve, it will be about brightness. When we talk about the steepness of the gradient curve, it will be about the contrast. Okay. Changes in the gradation curve correspond to changes in the histogram. So when you change something in the gradation curve or the HND curve, characteristic curve, it will correspond to changes in the histogram. Okay, so the position of the histogram left to right corresponds to the overall image brightness or density, and the shape of the histogram corresponds to the image, contrast, or grayscale. So to simplify it, just explained a while ago na si brightness, it refers to the centering no, of the histogram, and then si steepness of the gradient curve is for the contrast or grayscale. In other words, from a graphical standpoint, the histogram from the actual projection is moved and reshaped until it closely aligns to the reference histogram. The final display of the image is the result of this realignment. Okay. And siya. For example, this is your HND curve or sa histogram po, pwede na siya. Okay. So, as you can see, pag straight line portion ganiyan siya, there is no change. Okay. Pag naka-straight line lang yan siya. But if you change it from this area here, from the straight line into this graph, itong curve na ito, that means that you have changed both the brightness and the contrast of the image. Okay? So for example, ganito yan siya. Okay, wait lang. Yan. Okay, so if this is your characteristic curve, for example, if you make it steep, if you increase the steepness of the image or of the curve, that means you are increasing or you are fiddling or adjusting the contrast. No? Okay, but if you're moving it from left to right, okay, you are adjusting its brightness. Okay, so hindi man siya masaka. Okay, so basta pag saka na siya, you're making it steep. Okay, you are adjusting the contrast. Okay, and for example, I have another video here. Okay, so as you have seen in the video, diba, as I have maneuvered my mouse from up to down, the contrast was increased and decreased. So pag inakyat ko yung mouse pointer ko from up, it increases the contrast of the image. Pag down, it decreases the contrast of the image. And when the video, when my mouse pointer was moved from left to right, it will adjust the brightness of the image. So from left to right, it will increase the image, and then from right to left, it will decrease the image brightness. Okay, so that's it for the video. Okay, so in order for us to rescale the brightness, in automated rescaling of image brightness, formulas are applied to the actual data from the projection taken to align its position with that of the ideal reference histogram for that anatomy. So in this portion, seeing parang you can compare it from the, as I've explained a while ago about the LUT. Diba? There is an ideal na LUT, and there's this LUT that I have acquired from the exposure of the PSP plate. Okay, so this one is the ideal LUT or the ideal histogram, no, and this is the new exposure that we have acquired. Okay, so since we need to align it with the reference histogram or LUT, we have to adjust its, what do you call this? The exposure, okay, or the brightness, sorry, brightness. Auto rescaling will fail if exposure field edges are not correctly detected by partition pattern recognition software, or if unexpected material such as metal within the field of exposure skews the data from the exposure field recognition. Okay, so di siya mag-rescale automatically, okay, or it will not adjust the brightness automatically if the field edges of the, or the collimated edges was not detected by partitioned pattern recognition software. Okay, or if na unexpected material such as metal on the exposure field or in the field of exposure, and the contrast media put, of course. Okay, so again, the software is called partitioned pattern recognition software. So as you can see, again, this same figure. In this figure, imagine that your goal is to make the curve B identical to curve A. The first and simplest step would be to simply align the center points of the curve right to the left on the radiograph. Graph B is positioned farther to the right, indicating higher value. So that means your brightness level for this new exposure or the exposure we have acquired is brighter than the reference na LUT. So to move it to the left, simple subtraction of a fixed amount will suffice. Yeah. Now, if curve A represents the ideal histogram resulting from the LUT for a particular radiograph, then curve B would represent an overexposed image which would normally appear too dark. To locate the exposure indicator, one must find the midpoint of each curve line, or each curve, sorry. Okay, so the image for curve B pala is overexposed, so that means it's too dark, it's not too bright, okay? So the new exposure that we have acquired is an overexposed image, so that means we have to align it with the ideal histogram or from the LUT. Okay, so dapat ma-align natin siya dito. So we'll have to decrease the values from 2.7 to 2.4. So that means it will be, we have this, what do you call this? Kani ang mabawas in order for this new exposure to be aligned with the ideal exposure. Okay, so in order for us to acquire the exposure indicator, ito po siya ang formula. Okay, for each histogram, this represents the average exposure, also used as the exposure indicator. So for the average exposure for the new exposure that we acquired is 2.7 and the ideal exposure should be 2.4. So in order for us to acquire the exposure indicator, so we'll have to subtract here 2.7 minus 2.4, which is 0.3, and then 2.7 minus 0.3, which will be that will be your exposure indicator, which is 2.4. So complicated kayo sa book, but all you have to do is just subtract B minus A, and then you'll have the exposure indicator. Okay, we could request the computer to simply find the difference between these two average values by subtraction. We then have the computer subtract the difference from all pixels in the overexposed image, where Bn is the new position for the curve B. By subtracting this fixed amount from every pixel in the original radiograph, an identical overall brightness or average density is achieved. So when we subtract B from A and then C, the result of this will be subtract to B. That will be your new position of your curve B, okay, which is now aligned to the ideal histogram. Okay. Now, in order for us to rescale contrast na naman or the grayscale, ito siya. Without post-processing manipulation of the image, most radiographic techniques designed to demonstrate bony anatomy will result in soft tissue areas that are too dark in the image to be of diagnostic value. Conventionally, soft tissue techniques were required to produce separate images of these areas, which then depicted the bones to life. So for example, as I have said a while ago, in order for us to acquire contrast yun na optimal, we need to identify if ano ba talaga ang gusto ng doctor na makita? Is it soft tissue or bony detail? So if it's bony detail, we have to sacrifice your soft tissue because bony detail naman din kasi ang required ng doctor. Okay? So for instance, the patient was na-aksidente siya and he acquired a fracture. So ano ang i-focus natin? Is it the bone or the soft tissue? Of course, we will focus with the bone. Okay? So ayan siya. So we have another of the histogram here. Or, sorry, not histogram, it's the characteristic curve, H and D curve. Here, the gradient curve. The figure illustrates graphically the concept of compressing the dynamic range, which results in a shorter grayscale curve vertically. Okay, from A to B. Okay, so from this contrast, which is a long scale contrast, as you can see naman, mahaba ang kanyang curve, and then the latitude is also wide. Okay, so in this area here, in this picture here, it was compressed in order for contrast to be increased. Okay, in order to acquire shorter grayscale contrast. Okay, The toe or the bottom of the original curve represents extremely light densities in the image. Compressing the curve brings these densities up to a darker level. Okay, darker level, and at the same time, extremely dark areas on the top of the image represented by the shoulder of the top of the curve are made lighter so that details can be seen. So you're going to compress this one, okay, so that high contrast will be achieved. This compression is done mathematically by the computer after defining a midpoint average brightness or density level. The computer progressively reduces pixel values above this point. So bawasan siya in order for it to be compressed here, and progressively increases pixel values below it. Okay, so in order to achieve this one, magbawas tayo ng pixel values here and mag-increase tayo ng pixel values here. Okay? And then we have what we call tissue or contrast equalization. On the other hand, DRC or dynamic range control is especially useful in bringing out image details that are present within the image but obscured by excessive density. A significant improvement overall over conventional radiographs is that soft tissue areas are well demonstrated while maintaining proper density from bone detail. So we can achieve both bony detail and soft tissue demonstration in this, what do you call this? In this function, which is the dynamic range control or DRC. So as you can see in the picture, this is an overexposed image. Okay, so as you can see, sunog, hindi na makita ang lung markings of the, hindi na makita ang lung markings, okay? With the application of the DRC, we are able to see not only the soft tissue markings of this area here, di ba, mas naklaro na ang lung markings here and then also here, but we also have attained the bony detail. So as you can see here, di makita masyadong ribs dito, but as you can see here, it can be mas klaro na siya compared in this area here. Okay, so both bony detail and soft tissues are seen in this function. Okay, for Fuji's dynamic range control is somewhat more involved than simply compressing the grayscale curve. A DRR function sets the range of the new curve to which the original will be compressed. So the DRR function, siya ang nag-compress ng curve, okay? The DRR. And then a DRT function selects one of the 20 types of software filters to apply to this set of data. So the DRC Mangod, which is developed by Fujifilm, it has an pre-installed 20 filters, software filters. Murabag ka na sa Instagram that we have different types of filters. In this here, we also have filters, okay, so that the image will be much better in quality. And also, a DRE function sets the level of enhancement to be applied or strength of the filter, customizing the final grayscale to the anatomy to be demonstrated. Okay, as a side benefit of dynamic range compression, computer memory space is saved because a narrower dynamic range means there are fewer gray levels to keep track of. Okay, to summarize it, the dynamic range control has three types or three functions. We have the capital DRR, which compresses or expands the curve, depende kung anong gusto na contrast ni Radtech. And then we have the capital DRT na function, which selects one of 20 types of software filters to be applied to the image or to the set of data. And we have DRE, capital DRE functions that sets the level of enhancement. So the strength of the filter ba, kumbaga, kung sa Instagram, butang ko filter, gano ka strong ang filter ba na ilagay sa image. Ganun. Okay? And now we go with frequency processing. Frequency processing breaks the image down into sine wave functions in order to manipulate them mathematically and then resembles these sine waves back into an image. So in frequency processing, same lang siya nung aking igawa sa video. Okay, so as you can see, in the video, image lang siya, but if you're going to transform it into sine wave functions, okay, when we say sine wave, ano yan siya? For example, yeah. So this is an example of the sine wave. Okay, di ba ganyan? So in frequency processing, no, the image will be transformed, no, into a sine wave function into this one so that mathematical calculations will be easier. Okay, and then if mathematical manipulations are done, it will be transformed. The sine wave functions will then be transformed back into an image. Okay, ganun lang siya. And then now we go with smoothing. When all of the values in a kernel, when we say kernel, kani siya. Okay, 3x3 kernel, ito siya. Okay, are greater than 0 and equal as was shown in figure A. Yan, figure A. Smoothing occurs in the image as noise, and noise is reduced with an attendant slight loss of edge contrast. So when we do smoothing, there is reduction of noise. But ang edge contrast ninyo or ang edge enhancement ninyo is there is a loss for it. Okay, for example, pag mag-edit ng picture, di ba? When we want to smoothen the image, we have this function in the Photoshop or Instagram. Okay, so as you can see in the picture, the oiliness, some of the characteristics, the wrinkles of the image is then smoothened here in this area here. Pero there is loss of edge enhancement. So as you can see here, dito na area here, dili naklaaro ang edge ni sa kanyang nose dito po na area. Okay, so mas detailed pa siya dito, mas taas ang spatial resolution dito compared here because yun nga, when we smoothen the image, there is loss of edge enhancement or the spatial resolution. With the structural lines, they are no longer that much visible compared to this previous one. Okay. Smoothing is a form of low-pass filtering which removes the smallest details in the image. So, gina-uniform niya tanan. For example, kani siya in 1 pixel, no? Same sila tanan og values. That means same lang po sila og brightness or density in the image. Okay? And then we have this what we call edge enhancement. Okay? Edge enhancement, on the other hand, is accomplished by high-pass filtering. So kung si smoothing, low-pass filtering, edge enhancement is high-pass filtering, which suppresses the larger structures and background areas of the image. Okay, so these act as opposites. So excessive noise reduction can lead to a loss of detail, whereas excessive edge enhancement can introduce visible noise in the image. Okay, so for example, edge enhancement is in this picture. So as you can see, edge is have their own value, pixel value compared to the center one. So that means edge lang yun ang na-enhance. Okay, for example, in this picture, yeah. So as you can see, ma-identify niyo agad kung saan dito ang na-edge, nagawa ng edge enhancement. So for example, ito siya. Okay, so as you can see, the edges of the screws are more identified. The spatial resolution is high because the structural lines are visible, but there is an increase in noise compared ninyo siya dire. Okay, dagan siya speckled appearance in this image compared to this image. Okay, so as you can see here, mas lesser ang kanyang noise, but the edge enhancement is not that great. Okay. So always remember that excessive noise reduction can lead to a loss of detail. So the more you decrease the noise, comparing yung siya dire, noisy, and you have to decrease the noise here, the detail is not that great with the screws and other anatomical structures, diba? And then, whereas excessive edge enhancement can introduce, of course, visible noise. So the more you enhance the image, the edges of the image, the more noise will be applied into the image. Okay? So that would be all for this lesson. I hope you really understood the lesson. But if you don't, please message me so that I can, simplify or at least man lang ma-clarify siya. No? Para masabtan din niyo. Because the goal of this subject man is, the goal of school is for you to understand the lessons. Okay? So that you can apply it in your profession. So, also, I have a correction manggod sa akong slides. Sa slides ko po. So, diba, as I have said previously sa prelim period that, for example, yung si TFT. Si TFT, the storage capacitor, stores the electricity or electric charge, and then the TFT opens and it will lead to the liquid crystallis phase. That is wrong. Okay? I stand corrected. Pasensya na po, mali po yun siya because the TFT will lead the electric charges towards the data lines towards the amplifier as I have said in this PowerPoint. Okay? So yun lang siya. I stand corrected. Hindi siya directly sa liquid crystal display because it will be processed first by your computer. Okay? So that is all. Thank you so much for listening. Please, 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 I encourage you to ask questions if you have difficulties in understanding because I'll try my best to let you understand this lesson because ako po na humana, naglisod po ko og sabot. Okay? I find it hard to understand. So if you have any questions, please do not hesitate to ask, message. Okay? Thank you so much. Goodbye.